Hello, Mason. Hope you're doing well. So I want to kind of talk about slope-intercept form and look at the different ways that you have seen it thus far. And there's actually other ways you can see it, but this is just how you've been exposed to it thus far. So if you had an ordered pair, let's say that was 2, 3, let's let it be 4, 5. We said, okay, we want to write an equation of the line that passes through these pair of points. Well, let's first find the slope. So remember, it's vertical change over horizontal change. Or it's y1 minus y2 over x1 minus x2. Or it's y2 minus y1 over x2 minus x1. The 1s and 2s, these numbers are just the order. So like this is the first x, that's the first y. That's the second y, that's the second. That's the second x, that's the second y. Sorry about that. So that's all that means. Just so once you pick the order, you're coming from the same ordered pair. So if we said, let's just say we happen to use this to find the slope. So we say 3 lose 5, 2 lose 4. So that gives us a dead of 2. That gives us a dead of 2, which we know is the same as negative 2 divided by negative 2 is 1. So if we take that, let's go ahead and push this up. Say, okay, that's the slope. Now we say, well, let's look to plug that in. So we say, well, we know the y, because we're still trying to find, we don't know what the y-intercept is, we know what the b is. So if we know that the y is 3, the slope is 1, the x is 2. So we have 3 equals 2 plus b, so b must equal 1. So we know that the line is y equals, because remember the slope is 1, so 1x, or just x, plus 1. Well, to confirm we're right, let's look at the other ordered pair. So we can come back up to the top and say, well, what ordered pair are we doing with? Oh, we deal with the other one's 4, 5. So let's take the 4, 5, and let's plug that in. We know 5 equals 5, so wow. So the linear equation we created with these two ordered pairs is y equals x plus 1. So that works. Now let's look at a different way. What if they gave you an ordered pair of 2, negative 3, and let's say they told you the slope was 1/2. Well, for this, it's literally all you're doing is plugging it in. So y equals, again, mx plus b. So we know that the slope is 1/2, so in place of m we put 1/2. Y is 3, x is 2, we don't know what b is, so we say negative 3 equals 1/2 of 2 is 1, 1 plus b, so then b must be negative 4, so our slope is y equals 1/2 x. That's not a plus, it's a minus, remember, 4. So that would be your linear equation for that one. So that's how you do the ones like that. Now, when we look at something like this, and I know this is new for you, we say Major is driving a remote control car at a constant speed. He starts the timer when the car is 5 feet away. Well, the big thing is thinking about on a coordinate plane. So if this was the feet, that's our x-axis, this is the distance. Okay? So, if we think about it, he keeps traveling, so sorry, I made a mistake. Sorry about that. This should be time. This should be time. this should be distance. Sorry about that. Distance and feet are the same thing. I don't know why I put them on two different axes. That was my fault. So think about it. This is 0, 0. So if we think about it, after, let's say this was 5 seconds. Well, after 5 seconds, he's driven so many feet, right? Because after 1 second, because that's 1 second, 1 foot, 2, 2, 3, 3, so on and so forth. So the longer amount of time you drive for, the further you go. So that's what it looks like. So if we just say, well, let's look at this data. So Major is driving a remote control car at a constant speed. He starts the timer when the car is 5 feet away. After 2 seconds, so time, so x, so after 2 seconds, he's 35 feet away. Okay, well, let's think about this for a second. So we have that ordered pair, because at the end of two, he's 35. So it actually be more like this, but that's okay. So let's make sure we're reading something though, and I apologize because I just reread this problem to myself, Mason. So he starts the time when the car is 5 feet away. So technically, at the end of 2 seconds, he didn't go 35 feet, he went 30 feet. So this is actually be 2 and 30. Now the cool thing is, when he started the car, wasn't he at 0, 0? Or 0, 0? So when we go to apply that, we say, well, wait a second, if we're going to write a linear equation for this, well, if we think about it, we went from 35 to 0, and then, we went from 30 to 0 and 2 to 0, so our slope is what? 15. Okay? So if our slope is 15, we want to write that into a linear equation. That's telling us that think about it. Why is that 0? Because it crosses the y-intercept there. So for every 15 feet, it takes 1 second. So if we want to say, well, at the end of 10 seconds, so if I went 15 feet in 1 second, well, how far do I go in 2 seconds? I go 30 feet. How far do I go in 10 seconds? I would go 150 feet. So on and so forth. So just to give you an idea how that works. And I apologize for this confusion up here because 2 and 35, yes, in 2 seconds he went 35 feet away, but the trouble is we have to remember that he had already gone, that he didn't start the timer until the clock was already, until the little car was already 5 feet away from him. That's why I turned this back into a 30, just so you understand why that becomes a 2 to 30. The 0, 0, that's the starting point. That's right here. That's, you remember, if the car hasn't moved, right, it's not going anywhere, it's a 0, 0. At the end, then they let it go for 5 feet. Then they started the timer. Then at the end of 2 seconds, right, they knew it had gone 35 feet, but they'd already gone 5 feet, so technically we have to think about what that controls. So anyway, I hope that helps a little, and we will catch up on soon. Thanks.